Professor Bialis here. In this video we're going to be covering section 10.7, which talks about complex numbers. Okay, now complex numbers aren't like difficult numbers. Okay, they're numbers that include what's called an imaginary component. So before we get into the complex numbers, I want to talk about that imaginary component. The imaginary component is based on the imaginary unit. Now the imaginary unit is simply defined as the square root of -1, and we are going to represent that with I. Now that's not a variable because it is defined as something. It's almost like pi, okay? Or when we get into logarithms, that number e, okay? And I did say the number e, but it's not just a symbol that's unknown. It's a symbol that's defined as something, okay? Now, the other thing I want you to take out of this is if we took this equation here and we squared both sides, that would tell us that -1 equals I squared. Okay? One thing that you want to remember when we're dealing with these I values is you never want to leave an exponent on an I. You always want to simplify it down. And I'll show you how to simplify large exponents at the end. But when you ever see an I squared, convert it back to a -1. Okay? Now, keeping it simple, normally in the past when we had, let's say, square root of -9, okay, we would just say that's not a real number, and it's not. But now we have imaginary numbers that can handle that. So what we're going to be doing is thinking of this 9 as a 9 times -1. Square root of 9 is 3. Square root of -1 is I. And that's all there is to it. Okay? A more simplified way of thinking about it is square root of 9 is 3 and the negative comes out as an I. Okay? It's a -1, but you can think of taking that negative sign out as an I. Okay? How about something like this? Now this is a little different because that 3 can't be taken out, okay? But the negative still can. So what we're going to do is keep that square root of 3, but then that negative on the 3 is going to come out as an I. Now sometimes when we write this, you'll see people write it like that. I personally don't really like that because it is very easy for that I to migrate underneath that radical. Here it's very clear that it's not inside the radical. This is a lot of times how a textbook would write it, and that's fine, but again, it does leave you open to misinterpreting what you're writing. Okay, so just be careful with it. I personally like putting that I in the front. Okay, how about something like this? Okay, now a lot of people think, oh, two negatives make a positive, but they don't intermingle like that when one's outside and one's inside of a radical. So what we're going to do is we are going to keep that negative there, break this 50 up into a 25 times 2, square root of 25 comes out as a 5, this negative comes out as an I, and then the 2 stays inside. And there is your simplified radical. Again, that -50 really has a negative, a 25, and a 2. The negative comes out as I, the 25 comes out as 5, and then the 2 stays. This negative sign here just drops down. Okay? How about something like this? Now, you want to look at that and say, well, product rule. I would just say -3 times -7 is positive 21. Okay, so you'd have square root of 21. The problem with that is the product rule applies to real numbers. These are not real numbers yet. So let's change them so that they are. Now, what I mean by that is square root of -3, we're going to think of as I root 3. Square root of -7 is I root 7. Okay, now just like if it was just a normal variable, if you say I root 3, that really means I times root 3. I times root 7. Okay? And then once we lay it out like that, you simply multiply those corresponding pieces. And we can multiply the 3 and 7 now because those are real radicals. Okay? So what we get is I times I is I squared. Root 3 times root 7 is root 21. Okay, but remember, never leave an exponent on an I. Okay, simplify it down. I squared is a negative 1. So what we're left with is a negative square root of 21. And that's all there is to it. Okay, again, if we just did the product rule, we would have gotten that square root of 21, but we would be missing that negative. And that's a big difference. So be careful and break it down as it should be. And there's your final answer. How about something like this? Let's see how this plays out. Now, first thing I would want to do is simplify these radicals down. Even if there was no negative here, I would want to simplify this just so I don't have such a big number underneath. So what I get is a 9 times a 3. Square root of 9 is 3. 3 stays underneath. So again, this 9 is coming out. The negative 3, remember the negative simply comes out as I. And we have that. Now, as it's written, you might think, well, there's 2 things being multiplied. There's technically 4. Everything here is one big product. So we can move things around any way that we need. So we have a 3 times square root of 3 times square root of 3 is just a 3 again. And then we've got I. So really what this is 9i. Okay? Let's do one more like this. How about that? Again, you want to maybe just reduce the 8 and the 2. You can't do that though because that square root of negative 8 is not a real number. So what we're going to do is simplify first. This is a 4 times 2. So square root of 4 is 2. That negative comes out as an I. And then you've got square root of 2. Now, that square root of 2 on top is a real value. And those can cancel out. So all we have is simply 2i. Okay? All it comes down to is making sure you simplify the radicals first, including simplifying out that negative 1 as an I. Okay? Now, let's bridge into complex numbers. These are all purely imaginary numbers that we are working with. When we deal with complex numbers, we are dealing with a combination of real and imaginary values. So a complex number is going to be a number of the form a plus bi. Now, a plus bi could be a minus bi. Okay, the signs could be different there, but you have a sum of a real component and then an imaginary component. Okay, so some examples could be 3 plus 5i. Real component's 3, imaginary component is 5. It could be negative 2 plus I. It could be 3 minus 8i. Okay, real component imaginary, real imaginary. Okay, it could also be 7. Okay, that's just a normal, natural 7. But it's also complex because if we needed to, we could always put plus 0i. Okay? Same thing if I had just a negative 3i. It's imaginary, but it's also complex because I could just say, well, my real component is 0. Okay? What I want to point out with this is these complex numbers are not standalone things. Okay? They're simply expanding the universe that we originally had. That universe being real numbers. So what we had before were natural numbers. Then we expanded and included that idea of 0 with whole numbers. Then we expanded, included the idea of negative numbers with integers. Then we expanded and we had rational numbers which included some decimals and fractions. Then we had a standalone irrational number, okay? And then we held all of that together as real numbers. All complex numbers do is expands it to another layer. So we're still including normal, natural, whole, integer, all those normal things. We're just now including more. So then this is where complex falls into the grand scheme of things. So whenever they talk about complex answers, that doesn't mean that you can't get an answer of 7. That just means you could possibly get an answer of this. When they talk about real answers, that just means I'm not looking for stuff like this. Okay, so again, this just gives you the opportunity to do more. Okay, now what we're going to be doing with the rest of this section is talking about how we can calculate with complex numbers. Add, subtract, multiply, divide. Okay, you're going to see it's exactly as you would hope. It's exactly as you would just intuitively kind of stumble into it. So let's start with adding. Let's say we have 3 plus 5i plus 2 minus 6i. Okay? That kind of looks like you're adding a binomial plus a binomial. That's exactly how we're going to be treating it. Okay? So when we're adding complex numbers, you just think of it as laying out all the terms and then adding the like terms. But in this case, we call them like components. So 3 plus 2 is 5. 5i minus 6i is negative 1i. It's as simple as that. With subtraction, very similar. Let's say we have 7 minus 3i minus 8 plus 9i. What would we do if that was just a normal polynomial? We would distribute the negative. Same thing here. And then we combine those like components. So 7 minus 8 is negative 1. Negative 3 minus 9 is negative 12i. It's as simple as that. Let's say we're multiplying. Let's say we have 2 minus 4i times 3 minus 5i. It would be really nice if that was just kind of like a FOIL problem. That's exactly what it is. So we're just going to FOIL that like we normally would. Okay? And at this point, we're treating those i's like a variable. But hold off until the end here. We've got 6 minus 10i minus 12i plus 20i squared. Okay? Now, remember what I said, though. Never leave an exponent on I. When you're multiplying, you're going to get a lot of I squareds. I squared was defined as negative 1. I squared equals negative 1. So really, 20I squared means 20 times negative 1, or negative 20. All you're really doing whenever you have a term that has an I squared attached to it, you drop the I squared and change the sign on the term. That's really all you're doing. So what we have is a 6 minus 20 is negative 14 minus 22i. And that's it. Let's do one more like that. Let's say we have something like 3 minus 6i quantity squared. Just like with a polynomial. When you're squaring something like that, write it twice and then FOIL it back. So I have 3 minus 6i, 3 minus 6i. I distribute to get 9 minus 18i minus 18i plus 36i squared. But remember, plus 36i squared simply turns to a negative 36. I drop the I squared, I change the sign. So 9 minus 36 is negative 27 minus 36i. And there we go. Okay? That is adding, subtracting, and multiplying. Now, dividing, they don't ever really say divide these complex numbers. What they say is, let me clean the board up here for a second. Write these in standard form a plus bi. Okay, so they're not going to say divide. They're going to say write it in standard form. So let's look at what this would be presented as. Let's say we have something like that. Now, that's not in a nice format because the I is in the denominator. I want that I in the numerator. That's really the issue. Okay. Now, this is going to act the same way as when we were rationalizing denominators, because remember, I is a square root of negative 1. That's essentially what we're doing. Okay. Whenever you have just a single imaginary term in that denominator, you don't need to mess with the 5 or the coefficient, whatever number it is. It's just the I. So I am going to multiply top and bottom by I. Because once it's I squared, boom, negative 1. No more I. Okay, so what I get is 6i. And then down here, I have 5i squared. Okay, but where's the I squared go? 5i squared is simply a negative 5. Again, I drop the I squared and I change the sign. Now, they wanted specifically a plus bi. A is always your real component. There is no real part of this. So what I'm going to have is a 0 for my real part. And then I have a negative sign, 6 over 5i. Once the I is on top, it can very easily just be pushed off to the side. When it's on the bottom, it's stuck there. But when it's on top, it can fall out to the side of the fraction. And there is your standard A plus BI format. Okay, so whenever you just have a regular I imaginary term on the bottom, just I, multiply top and bottom by I. Nothing more than that. What happens when you have a full complex number? Let's say you have something like that. I don't want to multiply by I because then I would be distributing and then I'd end up with an I on the 2. So what I'm going to do is the same basic thing I did with rationalizing, just a general radical in the denominator. And that's when we used the conjugate. In this case, we're using the complex conjugate. So all I would do is I would multiply top and bottom by the complex conjugate, which is 2 plus 3i. Same terms, just opposite sign in the middle. That's it, okay? If there was a negative out here, this would still have a negative. I just changed the sign on that middle part of the complex number, okay? Now, what that should do is clear out all the I terms in the denominator. Make sure that happens, because if it doesn't, maybe we picked the wrong thing. So what I get is a 4 plus 6i minus 6i minus 9i squared. Okay, now I still see a lot of i's, but these cancel. And remember, this turns into a plus 9. So 4 plus 9 is 13. The numerator is going to work out how it works out. We got to do it correctly, obviously, but it doesn't have to be anything special. Like the denominator, there better not be any i's. Okay, the numerator though, we've got 6 plus 9i plus 2i plus 3i squared. Now I can clean that up by first changing this to a negative 3. 6 minus 3 is 3. 9 plus 2 is 11i. And we're here. Okay. Now if we're getting loose with our notation, that's perfectly fine. But if they specifically say a plus bi, I need to separate this into a 3 over 13 for my real component, and then 11 over 13 I as my imaginary component. Be very careful with the instructions. If they specifically say a plus bi format, it needs to be broken up. Okay? And that's pretty much it with calculating complex numbers. Okay, the last thing I want to talk about is when we have a higher exponent attached to the I. We've dealt with I squared, you just drop it, change the sign, no big deal, okay? But what if it's an I cubed, I to the 4th, I to the 52nd, something like that? Okay, how are we going to handle that? So let's clear the board here and then finish up with that. Okay, now we started this whole topic with I and then I squared equals negative 1. Now what I have heard from a lot of students is that teachers typically lay out I squared, I cubed, I to the 4th. And then what you do is basically cycle through those 4. That's perfectly fine. However, you don't need I cubed and I to the 4th. You can do the job with just these two. Okay? So let's see how we can do that. Let's say I give you something like this, I to the 32nd. Okay, what the heck is that? How am I going to use these to simplify that? I can't be left with an exponent on I. So what I'm going to do is I'm going to write this in a way that involves I squared. Think back to your exponent rules. I to the 32nd could be written as I squared to the 16th. All I did was take 32 divided by 2. Because when I have exponents like this, I multiply them. That gives me the 32. Now what does I squared equal? Negative 1. Negative 1 to the 16th, that's an even exponent. So if I have an even number of negatives, they turn positive. 1 to anything, any power, is still going to be 1. But it's going to be a positive 1. And there we go. I to the 32nd, that's 1. End of story. What if I give you I to the, let's say, 46th? Okay. First thing to do is introduce that I squared. So I have an I squared to the what? 23rd. Because 23 times 2 would give me back that 46. I squared again means negative 1. Negative 1 to the 23rd, this is now an odd number of negatives. So I end up with a negative 1. Okay? Now, what happens when it's not divisible by 2? Let's say we have I to the 53rd. Okay? If I divide that by 2, it's not going to come out evenly. So what we're going to do is take that odd I out of it. Okay? If you have an odd number of i's being multiplied, then take that oddball off to the side. What I mean by that is lessen that by 1 and separate that extra 1 at the side. If I were to look at this, I would just add those exponents. 52 plus 1 is bringing me back to the 53. Okay? Now, this I is going to be along for the ride, but this is the one that we can now manipulate like I manipulated these. So I to the 52nd I'm going to think of as I squared to the 26th. Don't forget times I. 2 times 26 gives me that 52. I squared is negative 1 to the 26th times I. Negative 1 to the 26th, an even number of negatives, gives me a positive 1 times I, which is just I. That's it. Okay? That's a good one more. Let's say we have I to the, let's say, 35th. Okay, again, it's an odd number, so let's take that odd I out of it. I to the 34th times I. Okay, that brings me a total of 35. I'm going to work with that 34 now. I squared to the 17th. Just 34 divided by 2 gives you 17. Negative 1 to the 17th. Odd number of negatives keeps it negative. And there we go. When you're dealing with a high power of I, these are your only 4 possible outcomes. That's it. Okay? If it's even to begin with, you're either going to be a 1 or a negative 1. If it's odd to begin with, you'll be an I or a negative I. Now, I would suggest you still go through that whole process to figure out what sign it is. Don't just guess, well, I think it's positive, or I think it's negative. Go through that process. It doesn't take long, and as you get better at it, it's very, very quick. Notice, though, all I knew was this. If you establish I cubed and I to the 4th, well, there's your 4 possibilities. You just need to know what multiple of 1, 2, 3, or 4 you're at. Okay? I personally don't think that that's necessary to memorize more. If you can do more with less, that's a lot more powerful than to try and memorize a bunch of different facts. So always try to memorize the least amount as possible to get any problem that I or someone else can throw at you. Okay, if you can memorize more, that should happen naturally. You want to force the necessary memorization. The extra memorization that makes life easy, that should happen naturally. Otherwise, it's very easy to get things mixed up in your head. Okay? So, as always, keep working hard. Let me know if you have any questions, and I'll see you next time.